This video demonstrates the best way to interpolate a sounding profile for anywhere in the world. There is one qualifier, however. You must have other nearby soundings that are representative or reasonably close to your target interpolation location. The minimum program requirements needed to interpolate soundings are the RAOB basic program plus the optional standard cross-section module. But before beginning an interpolation, let's get the latest sounding data using RAOB's download function. To do this, select the File menu and then the Download Data option. Then select the current .ray-wins download item. And then click the Download button and always remember where you saved the data. If you know of a better or prefer a different data source, then please use it. You can configure other data sources for automated download by using this Add button. Note, however, that many data sources do not allow or restrict automated downloading. Now that we have the latest sounding data on file, we can proceed to the cross-section functions. To do this, select the Displays menu and then the cross-section option. Okay, now that we're in the cross-section module, our goal is not to create a cross-section diagram per se, but only to select the best set of local sounding profiles which you want to use for the interpolation process. So let's get started. Select the File menu, then the Create a New Cross-Section option. Here we have options to create a time-height diagram or a cross-section. In this case, we want the cross-section option, and then the Click Here to Continue button. Click on the Add a Sounding button and select your recently downloaded data file or other sounding data of your choice. If your data source display is not already set to the Map function, then just click on this Map button. We have pre-selected the United States map region, but you can select any global location with these regional options. For this demonstration, our target interpolation point is the Four Corners region, which is bounded by the four states of Utah, Colorado, New Mexico, and Arizona. There are three soundings which surround and are closest to the Four Corners region. They are Flagstaff, Grand Junction, and Albuquerque. So now let's create the cross-section. First, left-click the mouse on Flagstaff, then click on Grand Junction, and then on Albuquerque. The red line indicates the cross-section path. When done selecting sounding data, then right-click the mouse and select Create Cross-Section, where RAOB will automatically transform the three soundings into a cross-section diagram. And here's our cross-section diagram with our three selected soundings, Flagstaff, Grand Junction, and Albuquerque. But before we interpolate a sounding for the Four Corners region, let's first assume that our target area lies directly between any two soundings. For example, let's say the target location is about 100 nautical miles from Grand Junction toward Albuquerque. In order to create this sounding, we first select the Interpolate menu item. Then slide the blinking box, which is located below the diagram, to a location approximately 100 miles between Grand Junction and Albuquerque. Notice the target location data below the blinking box, which also shows the 100-mile distance. After your target location is selected, then click on the Interpolate New Sounding button located above the diagram. Your newly interpolated sounding is immediately displayed as a mini pop-up image. You can now save the sounding to further analyze on a SCUT diagram. But for now, let's clear the screen and move on to the Four Corners interpolation. When needing to interpolate a sounding that does not directly lie between two soundings, such as the Four Corners region, then you must first select the Display menu and then the Composite Sounding Map option. You can now see a two-dimensional surface map of your three cross-section soundings using a standard latitude and longitude coordinate system. A blinking crosshair image marks the target location for this interpolation. It is initially placed in the middle of the map where its coordinates and elevation are displayed at the upper right. The target location can be changed simply by moving the crosshair image with mouse click and drag actions. The Four Corners region is approximately located at 37 north and 109 west, where we'll set the crosshair image. Once your target location is set, you can then select the Interpolate menu, where you have two interpolation options, distance weighted and equally weighted. For this purpose, you want to use the distance weighted option, where greater weight is given to soundings that are closer to the target location. So let's click on the distance weighted option. Now we see the target latitude and longitude values listed in the right side panel. We also see an estimated elevation value for the interpolated sounding. It is very important to edit the elevation to reflect the target location as best possible. In this case, we'll enter an approximate value of 1500 meters, and then click on the Interpolate Sounding button. And as with the prior interpolation method, we are again presented with the option to save this interpolated sounding to file. And this time we'll say yes and give it a file name. Next, we are presented with an option to add supplemental information, which will also be saved with the interpolated sounding file, and then select OK. So now your interpolated sounding is saved to file for your use. It's now available for immediate use simply by clicking on this expansion icon. Here's the interpolated SKU-T with file name and supplemental information. You must be aware that the weakest point of any interpolation is the surface data and associated boundary level. The majority of key thermodynamic indices greatly depend on the surface and boundary layer data, so it is very important that you now adjust this data as best you can. You should now edit this new sounding to ensure the surface temperature and dew point data accurately reflect conditions at your target location. Then adjust the boundary layer data as best you can. And I should point out, you should also edit the surface and low-level wind data as appropriate. To do this, first call up the data editor from the Edit menu, and then the Edit Decoded Data option. This editor views the data in its raw format, from which you can easily alter temperature and wind data. In addition to its easy edit format, all changes are validated against basic error limits. Temperature data are edited from the Pressure and Temperature tab, while wind data are edited from the Height and Wind tab. And for those who have access to the optional Photograph and Interactive Program module, you also have the option to make these data edits graphically using click and drag operations. This edit method can provide a visual representation of the data changes, where you can watch the sounding profile and the alphanumeric data listing change with the data edits. And that completes the RAOB sounding interpolation video. Thank you for watching.